Okay. Loud and clearly. So can you hear me now? It's okay for you about the voice?
Yes, it's good.
Yes, ma'am. Yes, ma'am.
Okay, maybe
Mom.
maybe louder or more. Okay. Yes. So maybe let's begin about today's training. It's okay for you?
Yes, ma'am.
Okay.
Yes, for yes.
First, welcome to Reyee training. This is my first time about the global public training. And today our topic is about Reyee switch and AP. Of course, some key technology, not about everything, okay? So before this class, let's have a brief introduction about myself and about this course. And my name is Emily, and here is my email address, and this is my picture. In China, everyone take a picture, we use Photoshop to do a little different, okay? And I am the trainer of the Ruijie regional technology team, and over 6 years, focus on the training on the security, like the firewall and the routing and switching as well as something like this. And about this course, we have 3 hours. So it's a little long online because maybe everyone will think the time is too long, so we'll be tired. And we have 3 topics. The first one is about a Reyee switch. We will talk something about layer 2 technology, like VLAN, like FTP, like link aggregation, something like this. And the second part is about a Reyee AP. And this is very useful in our network, right? Because now everyone have the phone and we want the phone to reach the internet. So the main part, the main devices is the AP. And the third part, I will explain something about the Reyee service and some support. So besides the training, you also have other tools to get some support about the technology. Maybe you get some trouble and you want to do the troubleshooting. We have so many tools we can use in the Reyee. So this is about the course. And in my training, I have one requirement. Pay attention. If you have any problem, please directly ask me, or maybe you can directly to open your voice, or maybe you can write down on the chat window. After one topic of the technology, I will see the question and the answer with you, or maybe after the training, I also will explain the question for you. So if you have any problem, please directly talk to me. It's very important to me, and I think it's also very important to you. So this is about my requirement. It's clear for you? Yes?
Yes.
Okay.
Yes, ma'am.
Don't be shy, okay?
Sure.
So let's begin our today's training information. Because when I received I set the invitation on the Google, and I also get some suggestions and get some questions. If I don't have the basic technology, can I join the training or not? Actually, I have 3 questions for you. If you can give me the answer, I think it's very easy to enjoy the training. The first one, in our communication network, we have 2 very important reference modes. One is OSI and another one is TCP/IP, right? So how many layers of the OSI reference mode? Do you know how many layers?
7.
Yes, 7. I see so many. The correct answer. Yes, it's very good. 5. 5 is TCP/IP, right? So this is the first question. The second one, when we transfer the packets in our network, maybe the router, maybe the switch, maybe our laptop, we will use 2 address. One is IP address, right? So how many bits of the IP address? Do you know the answer?
16. 16. 32.
16
32, right? Yes, 32 of IPv4. I guess maybe someone know. Oh, who writes the answer? So many answers. Yes, this is 32. And besides the IP address, right? We also have another address. This is MAC address, right? So how many bits of MAC address? Do you know the answer? 48. Yeah, 48, right? Yeah, so about these three questions, if you know the answer, I think following the technology is very easy for you to understand, because I will explain the packets, how to do the encapsulation, and when the switch receives the packets, how to forward the packets, and all the packets we have to finish the encapsulation. We will add the information of layer 5, layer 4, layer 3, layer 2, and finally to be the binary and use a cable to transfer the packets out. So within the encapsulation, the very important parameter of layer 3 is the IP address. Of the layer 2 is the MAC address. So when the switch receives the packets, if the switch is layer 2, we will forward the traffic according to the MAC address information. So later, let's see the first topic. For example, very simple scenario. For example, now my PC1, and my colleague Jason, he also have a PC2. We belong to the same department, is the IT department. Now we want to use the phone to transfer the file with the two computers. And we already connect with the cable and give the IP address and also give the MAC address, right? So let's see the process. If I want to say, for example, I want to use the FTP to send the packets to PC2, before we send the packets, usually we will use a tool. This tool is ping, right? I think everyone uses a tool, right? To ping the destination is successfully or not. So let's see the process. How to finish the ping. About the PC1, we will use this PC and use the command on the DOS ping, and then to give the destination IP address 192.168.1.2, right? And then the PC1, the laptop will do the encapsulation to add the layer 5 information, layer 4, layer 3, and layer 2. We only focus on the layer 3 and layer 2. Let's see the process. PC1 will do the encapsulation, right? We will add the source IP address and the destination IP address. It's very easy to understand, right? Because I've used the tool on my PC1, so the source IP address is 1.1. The destination IP address is PC2, so the address is 1.2. And I have a question about the layer 2 information. Source MAC address is MAC address A, right? Because I use a PC1 and the network card already has the MAC address. But the question is, what's the destination MAC address? Who can show me the answer? What's the destination MAC address? Yes, someone says MAC address B, right? Should be MAC address B. But PC1 don't know. Why PC1 gets the destination IP address? Because on PC1, we add the command, is this one, ping 192.168.1.1. So that's why the PC1 can directly use this IP address and then fill in the destination IP address. But how to get the destination MAC address? We don't know, right? Because we don't use the command to tell PC1. So how to get this information? Very important protocol is ARP. Do you know this protocol? ARP is used to translate the IP address and the MAC address. And by default, ARP is a broadcast packet. That means PC1 will ask everyone who knows the MAC address of PC2. So PC2 receive it, will give a reply. But pay attention, at the beginning, the ARP request is a broadcast packet, right? Of course, if you want to know the detail of ARP, you also can learn some information about the RCNA technology, right? Before we join the training, I already show you how to register the e-learning account, and you can know something about the ARP on the RCNA certification course. And use this protocol, finally, we know the MAC address is PC2. Yes, is this related to ARP table? Yeah, at the beginning, the ARP table also is empty. Yes, so we will broadcast and then to get the MAC address information. After we know the MAC address is MAC address B, then the PC1 will encapsulation again, and the source IP address, the destination IP address, the source MAC address is A, and according to ARP, we know the MAC address is B. So finally, after we encapsulation successfully, then PC1 will send out the packets to PC2. And this packet is used to test the connection between PC1 and PC2. Actually, in our network, it's very easy to understand. If you want to send out a firewall, or maybe you want to send out some message, or maybe to test the connection, that means I will give you a packet and you can receive and give me a reply. That means the connection is okay. Yes. Can't record for the mate and said please ask the host. I'm the host. I already recorded the information and later I will show you about this one. Okay. So this is the process of the very easiest scenario of two PC and directly to connect with each other, right? The network is very simple. It's very easy to understand, right? So later in our real network, maybe the topology is a little complex, something like this one. Also, my PC want to take a communication with my colleague Jason, his computer PC too. We're still within the same IT department, and we want to transfer a file using the computer. But now the different one is my computer on the 3rd floor, but the Jason is on the 5th floor. So what's the problem about the before technology, before the topology? As we know, we have the limitation of the cable, right? The default, the maximal distance is 100 meters. So if we located in different floor, maybe the cable sentence is not enough. Of course, if you use one very long cable to connect with each other in different floor, it's not beautiful. So how to solve this problem? Who knows the scenario? Yeah, someone say we can use a switch or hub. It's correct. For example, now we will use a switch and to connect with two PC. Of course, if maybe one switch is not enough, we will use multiple switch, right? And to make the distance longer and they can connect with each other. So now we have to know how to work about the switch, because if we directly connect with each other, we can encapsulate the packets, then to use a cable to directly for the traffic. But now if we add the switch, how to work about the switch? Let's see the process. It's very important about the switch. Before we talk about the principle, let's see how many types of the Ethernet frame. Ethernet frame means when we finish the encapsulation and add the layer 3, layer 2 information, finally the packet we call is frame. If we use the Ethernet protocol, that means this is the Ethernet frame. By default, the switch use the protocol is Ethernet. So what types of the frame? Actually, the first one also we will see is the unicast packets. What means the unicast packets? For example, if I now send the packets and I directly send to the destination, this message I will send to Jason. So this packet we call is unicast. Yes, one-to-one communication. Like this topology, if the source PC sends the packets out and the destination MAC address is unique. For example, now the MAC address is the middle computer, right? So this packet we call is unicast packet. And this packet finally will be sent to the destination, and only the destination, the receiver will receive the packet and give a reply. And all the other packets will, all the other terminal will directly to discuss the packet. Yes, so this is unicast. And the second one is the broadcast packet. The broadcast packet special one is the destination MAC address or one, so should be OF when if you use the Wireshark tool to get the packets, you can see the destination MAC address. And all nodes in the broadcast domain will receive the packets. So if like this one, now the terminal send out the packets, the destination OF, and everyone will receive the packets and will see what's the information on the packets, and finally to decide to give a reply or not. For example, in the first scenario, the PC1, my computer will send out the ARP packets, right? The first ARP request is a broadcast packet. So everyone will receive this one, and to decapsulate packets and to see this message is sent to me or not. If no, I will discard. If yes, I will to give a reply. So the terminal will take the resources to deal with the packets. So two types. Actually, in our network, we have the third one we call is multicast, but this is not the key point in today's training. And then let's see why we explain two types. Because when the switch receives different type of frame, we will have a different action. And about the switch, we have two actions. That means two functions or two ways we have to finish. The first one is learning. Because switch connect with multiple terminals. When I receive the packets, I have to forward the packets, right? So maybe about switch, we have multiple ports. Maybe have 10 ports. I receive from port 1, and then this packet should be sent out all the rest, all the interface, or maybe the port 4, or maybe port 7, something like this. So who will make the decision? It's because it depends on your MAC address table. So this one is very important about the switch. So about switch, at the beginning, I have to make my MAC address table much entries as possible, so I can forward the traffic according to this information. If the entries is empty, I will do the flood. Flood means everyone will receive this packet. So if this action will waste the resources. So this is the first process the switch have to know, learn the MAC address, and add this information in the MAC address table. The second function of the switch, I have to finish the forwarding. Because I am the network device. When I receive the packets, my main work is to forwarding the packets. And how to forward the packets? According to the MAC address table. And when we check with the MAC address table, we have 3 actions. The first action is forward. Forward means like this one. If we have 5 ports about the switch, I receive the information from the first port, and then I will check with my MAC address table, right? And the MAC address table will show us you have to send out the packets from port 4. So finally, this packet will be sent out. This is the action of forward. The second function is flood. Flood means I also receive from port 1. But finally, which port will be sent out the packets? All the rest of the ports. 2, 3, 4, 5. 4 interfaces. So this is flood. Which packets we will take the action of flood? The first one is broadcast. The second one is unknown unicast. What means unknown unicast? Because about the forwarding, we see the switch will check the MAC address table and finally to decide, right? According to the destination MAC address. If I cannot find this information, this unicast packet we call is unknown. About this packet, we will flood. And the third one is discard. Discard means I also receive the packets from the first interface, but finally I will not for the packets. So this action we call is discard. So about the switch, totally we have 3 actions. And later, let's see the first process, how to learning the MAC address, how to make the MAC address table as much as possible. Let's see the process, it's very important. First, if the switch is at the first time to start, there is no entries in the MAC address table, right? For example, now let's show you a topology. There is a switch and connect with 3 terminals. And the first time the MAC address table is empty. There are no any information. On the table, we have 2 parameters. First one is the MAC address. The second one is the interface. MAC address, we will add from the source MAC address. And the interface is the receiving port. So these 2 parameters is very important. So this is the first time there is no entries. The second time, the PC1 will send out the packets. Maybe it's broadcast packets, maybe it's unicast packets, anything, some like the topology now, PC1 send out the broadcast packets. And then when switch receives the packets, I will add the information into the MAC address table at first. Pay attention which parameters will be added into the table. The first one, we will add the source MAC address information. Pay attention about this. So, and the second one, we will do the association with the receiving port. So this is a principle, how to learning the MAC address. So after we receive the packets from PC1, I will update my MAC address table, right? Add this information. The MAC address is the PC1 IP address, and the interface is the interface 1 to add this information. So this is the first action we have to learn. And then we have to forward the packets. About the switch, not only about to learn to make the entries more and more, the main function is to forward the packets. So later, the switch will forward the packets according to the destination MAC address information. But this packet is very special because the destination MAC address OS. So this is a broadcast packet. That means I will forward the packets from other ports, everything. In this topology, we only have 3 ports, right? So this packet will be sent out from switch port 2 and port 3. But pay attention, except the received frame. The packet will not send to port 1 again, otherwise maybe there is a loop. So this is the first one. I learn 1 entries and then to flood the packets. So this is the first step. Then the second one, when PC2 and PC3 receive the broadcast packets, right? Broadcast means everyone receive, everyone have to deal with the packets. That means maybe PC2 and PC3 will give a reply. Of course, decides on your real network. Not every broadcaster will give a reply. Depends on the real network. For example, if the PC1 send out the ARP broadcast packets, maybe finally only PC2 will give a reply. But some other broadcaster, maybe everyone will give a reply. In this topology, maybe 2 and 3 will respond to the frame, right? When we give a reply to switch, and this reply information also is a complication of encapsulation. So these packets will carry the source MAC address and the destination MAC address, something like this. And the switch receives the packets. I will add the packets information of the source MAC address, also the receiving port. So the switch will add this information into the MAC address table again. In this scenario, we will find the switch now have 3 entries, right? From PC1, PC2, and now we have 3 interfaces. And later, if now we have the unicast packet, for example, PC1 sends the unicast frame to PC2, and the source MAC address is PC1. The destination MAC address actually is PC2 IP address. When switch receives this information, I will also take the destination MAC address to match the MAC address table. Finally, we will find the MAC address is connected with the port 2. So this packet finally will be sent out to port 2 according to the MAC address table. I can see. Yes. I can meet the MAC address, and this is the interface, and then we will finally to forward the traffic, right? The packets finally will forward to port 2 to PC2, and the PC3 will not receive this information. So this is the function of forwarding. Of course, in this scenario, if PC1 send out the packets to PC3, and PC3 only will receive the packets. So this is a process. And about this process, pay attention. It's very easy to understand, and the switch, we don't need to give any configuration. This is a basic function of the switch. That means the switch will finish the learning automatically and forward the traffic according to the MAC address table. So you only have to power on the switch, and then the switch will finish the function automatically. But pay attention in your network. If your network is very big, maybe the entries of the switch is not enough. So this is the first problem you have to know. If the destination MAC address not located on the MAC address table, the switch still can forward the traffic to the destination, but the action is flat. This one we call is unknown unicast. So this action finally will send the packets to the destination, but also waste the resources. So this is the main problem we have to know. This is the action of the forwarding. And about the flood, this is the scenario as I say, if the switch receives a broadcast packets, multicast packets, or unknown unicast frame, and the switch will do the flood. Flood means except the receiving interface, I will forward the traffic to the rest of the interface. So this one is very waste the resources. But pay attention about these three frames, broadcast and multicast, we cannot control because the switch will forward the packets as much interface as possible. But about the unknown unicast, we have to do some control. For example, if the entity of the switch is not enough, maybe you can increase or change a higher performance of the switch to make the entries as possible, as much as possible. Or maybe the entries, you will see so many MAC address on your table. Maybe there are some problems like a loop, and we will update the table as possible in our network. So about the switch, we cannot forward the normal packets. So this is the flooding action of the switch. About the broadcast, multicast, and unknown unicast packets, we will do the flood. Like this action, I will receive from port 1 about the broadcast packets and match to the MAC address table. We will find two interfaces, right? Then we will send the packets. Send out from all other ports, but pay attention, except the receive port, because this is used to avoid the loop. So this is a flood. All the computer will receive this information. So this is a little complex topology on our network. Maybe two PC is not connected with the other because of the long distance. So we can use the switch to connect with each other. And there are some other problems in our network because we see about the switch, how to learn and how to forward the traffic. This is automatically finished by the switch. And in a little complex more scenario, let's see, like this one. Now our company not only have one department of the IT department, we still have a new finance department. And our requirement is if the broadcast from IT department, this packet can be flagged to all the terminal also belong to the IT department, but the finance department cannot receive the packet. So this is our requirement. How to meet this problem? How to meet this requirement? Who can give me some solution? If there is a new requirement, how to solve this problem? We want to stop the broadcast. Okay, I see the correct answer, VLAN. Or maybe do you already know my material before? Yes, this is our next technology about VLAN. So what is VLAN? Why we use the VLAN? Let's see this topology. We have multiple terminal, right? Some terminal belong to IT and some terminal maybe belong to the finance. So if we want to limit the broadcast domain, for example, when PCA send out the broadcast packets, and we hope only the blue one, that means the IT department, will receive the message. How to limit the scope of broadcast? And actually, if switch can know this requirement, what's mean? For example, here is a switch. We connect with 4 terminals, right? And later, if now with the terminal send out the packets, and I will tell the switch, this packet belongs to my IT department. You have to forward the traffic also to the destination belong to the same IT department. And the right terminal also will send the packet, carry the finance information. So if switch receives this information, and I also can recognize the packets, maybe finally I only will send the packets to the IT department, not to another department. But about the switch, they cannot know what means IT, what means finance, but I know the number, right? Maybe I will give the number for IT department and I will give another number for finance. So this number we call is VLAN, right? For example, I assign the VLAN 10 for IT department, and I will later send out the packets carry the VLAN information. The switch forwards the packet not only according to the MAC address, but I also will check the VLAN information. Yes, I will send the packet to the same VLAN. So this VLAN target, the VLAN tag is similar function like we want to add the IT or add the finance. So this is a function of VLAN. And about the right one, we will assign the VLAN for VLAN 20. So maybe the ether frame send out the packets will carry the VLAN 20 information. So the switch for the traffic, we see not only according to the MAC address information, we also have to check the VLAN. Yes. And later, let's see what's the information on the VLAN. Because as we know, maybe we only add the 10, and then switch will forward according to the 10. Then the other packets carries the VLAN 20, and I will forward according to the 20. So what's the detail about the VLAN? 10 and 20, as we know, because everyone could maybe create a VLAN as before, and then what's know the function of the number. But actually in the real network about the VLAN, not only about the 10 and 20, we still have some other information on the VLAN tag. If we use the VLAN on our network, this protocol we call is AO2.1Q. Pay attention about this protocol. AO2.1Q, because maybe when you do the configuration of the AP, you also see the parameter is AO2.1Q. That means you already add some information of the VLAN. So this is AO2.1Q. If we add the VLAN, this packet we call is AO2.1Q packet. Otherwise, we call the Ethernet frame is a stand frame. And let's see the information. We add the tag to the standard Ethernet frame header, and there's some information like this. Pay attention. By the standard Ethernet frame, we will have the destination MAC address, source MAC address, right? And the type, length, date frame. Date frame means the layer 3 and the upper information. and we have some track information on the FCS. This is a standard package. If we add the tag, that means we will add this part information in the layer 2. So the VLAN also belongs to the layer 2 part. And what's the information of the tag? Let's see. We have 2 parts. The first one we call it TPID, Tag Protocol Identifier. This is a fixed value. The value is 8100. That means when switch receives the packet and I see the value is 8100, I have to forward the packet according to the VLAN information. So this is a fixed value. And the second part is a TCI, Tag Control Information. And this also has 3 parts. The first one is a VLAN ID. It has 12 bits long, indicates the ID information. Because the length is 12, so the range is from 0 to 4095. This is the range, but the available range is from 1 to 4094. So this is available. So maybe when you create the VLAN, or maybe in the future you do the practice, pay attention, you can try to create a VLAN 100, it's successfully. You can create a VLAN 2000, it's successfully. But if you want to create a VLAN 5000, it cannot work, right? Because we have the limit. That's why you can create successfully or not successfully. Of course, in some different switch, we also have the limit of VLAN number. For example, totally, maybe you only can create 16 VLANs or maybe 20 VLANs, depends on your real device. But the available range is from 1 to 4094. So this is the first part. And the second part is about the priority. It has 3 bits long. So the range is from 0 to 7. Maybe in your network, you have different priority traffic, like the voice, maybe like the date. And if the resources, the bandwidth is not enough, we hope the voice can be forwarded as soon as possible. So we can give different date, different priority. And this is a part of the VLAN, the second one. The third one is the CFI. This one have 1 bit long, and we know this part is enough. We have to focus on the VLAN ID and the priority. Okay, so this is a standard one. And then let's see the process. For example, in this topology, we have multiple terminal, right? PCA, PCB to PCN, multiple devices. And we divide the different terminal into different departments. Maybe VLAN 10 for IT, VLAN 20 for finance. And later, when the switch receives the packets, at the beginning, if we don't have the VLAN, the MAC address table will only have the MAC address information and the interface information. But later, if we use a VLAN, PCA send out the standard Ethernet frame. That means we don't carry the VLAN information. And later, the switch will add the VLAN information. Because about the switch, we have to do the configuration about the VLAN. Pay attention about this one. We see the switch for the traffic according to the MAC address information, and the switch learn MAC address and makes the MAC address table automatically. We don't need to do any configuration. But if we want to use a VLAN, we have to add the configuration. For example, like this topology, I add the port 1 to VLAN 10, port 2 to VLAN 20, port 3 to VLAN 10. And when my first interface, port 1, receives the standard Ethernet frame, later I will add the VLAN 10 about the standard frame, because we already added the configuration here, right? And later, after we add the VLAN information about the 10, if this is a broadcast, finally, the packets only can be sent out on interface 3 and interface N, because we add this interface into VLAN 10. That means VLAN 20 about the interface 2 and the other interface cannot be forwarded to the interface, because this interface belongs to VLAN 20. So in this scenario, the switch for the traffic not only according to the MAC address, but also focus on the VLAN. So this is the information of the VLAN. About the switch, if only can deal with one VLAN. What means deal with? Deal with means I receive a standard Ethernet frame. Without VLAN, later we will add the VLAN information and then force the traffic out. According to the VLAN information, if the VLAN is same with the other interface, I will delete VLAN. So this is the action we call is deal with VLAN. If one interface only can deal with one VLAN, this interface we call is access type. It's clear for you? Yes? So this is the first one of the access. So in this scenario, if we have two types of VLAN, VLAN 10 and VLAN 20, and we use the access VLAN, it's enough for you, right? Because different devices, we can use the different VLAN and to limit the broadcast. But pay attention. In our real network, it's impossible. All the terminal to connect with one switch is enough. Maybe between between two terminals, we have multiple switch, right? So the typical scenario is like this. PC1 and PC3 within VLAN 10, PC2 and PC4 in VLAN 20, and between them we have multiple switch. So there is a question. If we only have access VLAN, it's enough to force the traffic within the same VLAN or not? The access interface is enough or not? Let's see the process. If PC1 send out the standard Ethernet frame, and switch 1 will add the VLAN, right? And this VLAN should be VLAN 10. It's okay? And this packet cannot be sent out of interface 2 because interface 2 we connect with VLAN 20, right? So maybe this interface can be sent out of interface 20. If interface 20 can send out the packets and then delete the VLAN, that means the VLAN 20 have to belong to the interface 20 have to belong to VLAN 10 at the same time, right? Then the packets will be sent out and delete the VLAN. But if at this time, PC2 also want to communicate with PC4, the packets will send to switch 1, switch 1 will add to VLAN 20, right? The interface 1 cannot be sent out because the interface 1 belongs to VLAN 10. At this time, the interface 20 also cannot force the traffic of PC2 because this interface will already assign the VLAN for VLAN 10. That means at this time, PC1 and PC3 can communicate with each other, but PC2 and PC4 cannot. If we assign the VLAN for interface 20 to become VLAN 20, that means 2 and 4 can communicate with each other, but 1 and 3 cannot. So how to solve this problem? In this scenario, the interface 20 have to carry multiple VLAN information, right? So we have to use another type. This type we call is trunk. Yes? A trunk interface means we can allow multiple VLANs to pass through, and the frame will send out carries the VLAN information. When switch 2 receives this information, I will assign the packets according to the VLAN tag. So this is the function of the trunk. Yes, carries the VLAN 10 and also carries the VLAN 20 to the destination of the switch 2 and finally to forward the traffic. So this is a function of the trunk. And finally, when switch 2 receives the packets, I will delete the VLAN 10 and send the packets to interface 1. And 1 and 3 can communicate with each other. The same process, PC2 and PC4 can communicate with each other too. So this is the principle of the access and the trunk. That's why we say the trunk interface always may be used between different switches because maybe multiple VLAN have to be forwarded within one cable. But about the access interface, you only connect with the terminal because terminal cannot recognize the VLAN. So this is a trunk. And how to finish the configuration? If you want to use the VLAN to communicate with each other, if there is a topology, one switch and two terminals, how to finish the configuration? We have 4 steps. The first one, we have to create the VLAN. And the second one, we have to configure the interface. Also set up the VLAN type. Maybe it's access, maybe it's trunk, and also to assign the VLAN for interface. And finally, we have to check the VLAN state. So there are 4 main steps of the VLAN configuration. And later, let's see how to create the VLAN. The command is here, switch and VLAN, and then to give a VLAN number. Pay attention. If you only have the training and don't do any practice about the command, you will forget as soon as possible. So I only explain the main command of the configuration, and after the training or maybe in your work, you have to do practice maybe every day, maybe every 2 days. Otherwise, you will forget the command very quickly. So I only explain the main command for you. This is the command to create the VLAN. In the second step, you can give the name. Of course, this is the optional configuration. That means if you don't use this command, the VLAN also can work. But this one is help us to understand our network better. For example, VLAN 10 for IT department. And this is example. We create the VLAN 10 and give the name is IT. VLAN 20, the name is finance. And the second one, we have to create the access interface. Usually, this interface is used to connect with the terminal. To enter the port, enter the interface, and then to switch the mode to be accessed. And the third step, we have to add the port to specify the VLAN. Okay, so this one also is very important. That's why on the example, we say the first interface is used to connect with VLAN 10 because this interface we are ready to give the special VLAN. This is a command. Interface, this is the multiple interface. We will add this command in 2 interfaces. The first one is F01 and the second one is F02. Both of 2 interfaces which changes the mode to become access and gives a special VLAN for VLAN 10. Pay attention. About this example, we skip the step 2, right? We don't change the access port because about the switch, default mode is access mode. So we can directly to give the VLAN for the interface. About the interface 3, to switch the VLAN to become 20. So this is the configuration of access. The second one, how to finish the configuration of the trunk. We have to also enter the interface and to change the mode to become trunk. This is the theme of the access interface. And then we have to define the VLAN control behavior and for example, to allow which VLAN pass or maybe do not allow the VLAN pass, something like this. This is action. Allow the VLAN or maybe we direct it to remove the VLAN. This is a very important configuration. We can change the trunk native VLAN. By default, the native VLAN is VLAN 1. So here is an example. We can enter the interface and change the mode to become trunk, and later enter the interface to remove the VLAN 1 to 24 40 and 94. That means at this configuration, this interface not allow anything of the VLAN. And then we can add which VLAN can be passed through. So this is a command switch port trunk allow the VLAN, and we add the VLAN 10 and 20. So that means about the interface 2, we allow the VLAN 10 and 20 and can pass through. If we don't change the native VLAN, the native VLAN is VLAN 1. So this is a typical configuration. And later we can use the command. For example, if now you create the VLAN but the VLAN is not used, you can directly to delete. The command is no VLAN and then to give the VLAN ID. And we can use the show VLAN to check the VLAN information. Show VLAN, for example, like this. Show VLAN in our system, we have VLAN 1, VLAN 10, and VLAN 20. And the state is static. That means we create the VLAN manually. And which interface can allow this VLAN pass through? Pay attention, by default, only VLAN 1 exists on our switch, and VLAN 1 cannot be deleted. Pay attention. Yes, do not in your live network. Yes, this command can be used on the switch. Okay, so this is the basic configuration. And here is a summary of the VLAN. What's the purpose of the VLAN? VLAN are used to control the unnecessary broadcast domain. That means we want to limit the broadcast domain, and only within the same department can send out the broadcast packets out. Otherwise, we cannot receive this information. In this scenario, we can use the VLAN to control each other. But about the interface, how to deal with the message, I have a brief summary for you. Besides on the port type, access, and the trunk, we have two directions. The first one receives the message. The second one send out the packets. For example, if here is the switch and we receive the packets from this interface and want to send out the packets of this interface, if we receive the message without the tag, maybe the packet is sent out from the terminal. About the access and the trunk, if we receive the packets without tag, we will add the native tag. If we receive the packets with tag, that means maybe I receive this interface and the other side is switch. We will compare the VLAN ID. If the VLAN ID is same with the native VLAN, the packet will be received. Otherwise, the packets will be discarded. This is the action for access. About the trunk, if the native VLAN is same with the packet VLAN, I will receive. If the VLAN ID is different, I will check the permission list. If the permission allows the packets, we will receive. Otherwise, we will discard. This is the site when we receive the packets. But if we want to send out the packets of the switch, we also will check the port information. When we use the access interface, I will remove the tag and send the packets out. If we use the trunk, we will compare the VLAN ID. If VLAN ID is same with the native VLAN, we will remove the VLAN and then to send out the packets. If the VLAN ID is different, I will keep the tag and send out the packets. Of course, this VLAN should be located on the permission list. So here is the VLAN information. About this part, any question? VLAN is very important because not only used on the switch, maybe when we use on the wireless network, we also create the VLAN for the AP, maybe for the wireless controller. So VLAN is very important. If no problem, maybe our network still will be more complex. For example, if here is our topology, multiple VLAN, VLAN 10 and VLAN 20. Now use the VLAN, we can finish the communication within the same VLAN, right? Same VLAN can communicate with each other, but different VLAN cannot. But in this scenario, we still have another problem. We call it single point of failure. That means maybe this link is broken. PC1 and PC3 cannot communicate with each other. If the switch is broken, they also cannot communicate with each other. So how to solve this problem? Any suggestion? VSU. Yes? Any other solution? LACP? Yes. All of the solution is high available, right? So next part, I will explain one solution. How to increase the network high available and they still can relate with each other if one link is broken or one device is broken. So now maybe let's have a 10 minutes break. And within the break time, maybe we can do an exercise. It's a little tired because you already focused on the computer 1 hour, right? You can follow with the video and to relax your eyes. 10 minutes.
Blink for a minute.
Pay attention. 10 minutes later, we will come back and continue our training part. It's okay? Because about this video is 10 minutes. Of course, you can go and have a break.
Okay.
Okay, continue. Let's terminate. Emily. Yes, wait a moment. And I will show you with a video.
Exercise helps to regulate blood circulation inside your eyes. Take your time and let's begin. Blinking is an excellent way to relax your eyes. It has 3 functions. It helps grease your eyes, clean them, and give them a break from light. Exercise 5 times. Keep performing these 10 exercises regularly, and you will see great results within a week.
Okay. Maybe it's enough to. Okay.
Namamanhid ang mga kamay, baka kulang ka sa B vitamins. Hirap makatulog sa gabi, baka naman kulang ka sa jowa. Char, ang mga nabanggit kong sintomas ay pwedeng dahil sa iba pang sakit. Pero kung dahil sa micronutrient deficiency man yan, maaaring iwasan ito. Tulad ng
Okay, it should be come back. Hello, do you come back? Everyone?
Yes.
Yes. Do you finish the exercise? Because we still have 2 hours to do. You have to let your eyes relax and continue.
Very good, very
Okay.
good.
Maybe later I will show you the exercise video for you. Okay. So let's continue. At the first part, we explain something about the switch function, right? How to forward and why we need the VLAN. And in our network, if we still have the VLAN, but still some other problems in the network topology. Yes, thank you very much. Because you focus on, so maybe you can get as much as possible. Okay. And we say if in this topology one link or one switch is broken, they still cannot wait with each other. So we want to make our network stronger. Someone say, my voice is okay for you? Yes. Someone say we can use some technology like LACP, like VSU, like this. So let's focus on which protocol or maybe we can use to make our network stronger. For example, we can add one switch, right? And we can make multiple links with each other. In this scenario, if one link is broken, we still can use another way. And now this is technology time, okay? So if we want to make the topology to be like this one, there another problem. For example, if switch one, PC1 receives a broadcaster to switch one. So what's the action? This also is a review of the first part, right? Then the switch one will broadcast the packets, right? So this is the action of flood. And later, about switch 3 receives a broadcaster. I also will flood again because this is a broadcaster packet. And then the switch 2 receives a packet. I will do the flood and include the packets to connect with the switch 1. So in this time, there is a loop, right? If we have the loop, what's the disadvantage? Let's say about the detail. The MAC address will be updated all the time. Let's see this topology. For example, if PC1 and PC2 want to communicate with each other, and then the PC2, about PC1 will send out the packets, right? Before we talk about the detail, let's focus on the principle. With the VLAN, within a VLAN means now in this topology, they belong to the same VLAN. Switch receives the unknown unicast packet will be flat. So if PC1 send out the packets to switch 1, then the destination is PC2. But at the beginning, the switch entries is empty. So the switch 1 will use the destination MAC address to check the table, but we cannot find the entry, right? And later, switch 1 will learning at first. Learning means we will add the source MAC address information and the interface into the address table. So switch 1 will add the MAC address information and also the VLAN and the port information. Later, the switch 1 will flood. Flood means send the packet to port 1, port 2, and also port 4. So about the second step, switch 2 will receive the packets and then will add the information into the table. The same process, switch 3 will receive the packets and add the information onto the MAC address table, then will do the flood. Also the same, because the entry is empty. So this is unknown unicast packets. About switch 2, we will send the packets to switch 3. The same process, switch 3 will send out the packets to switch 2. And later, let's see the next step. Because switch 2 and switch 3 receive the packets both of the other side switch, so I will update the MAC address information. So this process is very important. In one MAC address table, one MAC only can connect with one interface. So now I receive the packets from the second port. So I will update the port information from the port 1 to port 2. The same process of the switch 2. I will update the interface. And then the packets will be sent out to switch 1 because I receive the unknown unicast packets from switch 3, and I will flood the packets. Also includes the first interface and send to switch 1. The same about the switch 1, I will update the packets. Later, I also will receive the information from switch 3. And switch 3 send to switch 1. Switch 1 will update again. So, switch 1 receives this unknown broadcast packet. I will send out the packets again within this time. So, when we will stop the forwarding until the network broken, that means the bandwidth is not enough, then I will stop. So this is a loop. Also, the packets finally will be forwarded all the time. This one we call is a loop, and we will update the MAC address all the time. So there is a circle. And how to solve this problem? Because why we need to add a new device, a new link with each other? Because we want to increase the network stronger, right? If one link is broken, we still can use another link to forward the traffic. But if we make the topology like this one, there is a loop. So how to get the stronger and also can provide the backup but avoid the loop? Who can show me the answer? Yes. There is a protocol for STP. We can deploy the STP. Actually, STP is used, for example, if the link, all of the link can work, we can logically to block the interface. Like this sentence. If we deploy STP, the logic blocking loop interface, that means, for example, like this topology, this interface will be blocked. Block means I will not forward the traffic, but the indicator is still green. Okay, if one link is broken or one device is broken, we can make the interface to be forwarding data and then forward the traffic. So this is the function of STP. And then later, let's have a brief introduction about the STP. How to make the decision which interface should be blocked or which interface can work to forward the traffic. So how to decide? This belongs to the principle of STP. The process of STP, we have 4 steps. The first one, we have to select who is a root bridge. In one layer 2 broadcast domain, only one root bridge. We call it root. And all the other switch we call is non-root bridge. Bridge means switch. And about the non-bridge, we will select the RP root port. And this root port will close with the root switch. And then to select the designated port, the DP interface. And the RP and the DP is the rule of the interface. Root bridge and non-root bridge is the rule of the switch. And decides the finally block all the remaining ports to avoid the loop. And as finally, only the RP and the DP can forward the traffic successfully. Block interface cannot. And they only can receive some protocol packets to detect the interface can work or not. Otherwise, I will make my rule to become a RP or DP immediately to forward the traffic. So how to select who is the root bridge, who is non-root bridge? Actually, the device will exchange some information. For example, to compare, my priority is higher than you, so you have to select to agree with me that I am the root and you are the non-root, and you have to select the root port, something like this. And this protocol we call is BPDU, Bridge Protocol Data Unit. And this protocol is used to select the rule of the network. It's very important. And about the process, we say we have 4 processes. The first one to select the root bridge. And about the root bridge, we will compare the bridge ID. Every switch we will have an ID. and two parameters. One is priority, the second one is a MAC address. So how to select? We will compare the priority at first, and the lower number will be better. If the priority is same, we will compare the MAC address. Smaller one is better. By default, all the switch priority is same. The value is 326768. So by default, maybe every switch the priority is same, but the MAC address is different. So we can compare the second step. And which interface should be blocked? We want to use a higher bandwidth interface to follow the traffic, so we can follow the packets as much as possible. And some lower bandwidth interface should be blocked. So in this scenario, maybe you can direct it to change the priority to change, and finally to change the rules of the STP. And the command, how to change the priority? First, we have to select to enable the STP. The command is like this: spanning tree mode STP. Of course, we have another mode like ISTP, MSTP, something like this. But the STP is the basic one. And then to enable the spanning tree and to change the spanning tree, the priority to be which value lower is better. And the priority will be configured global. So the priority is used for switch, not for the interface. So about the first one, compare with the bridge ID, we can select who is the root. And later, we have to decide the interface rules. The rest of the switch is non-root bridge. And the non-root bridge, at least one RP, root port. And we will compare the cost at first. Cost is calculated by the bandwidth. Higher bandwidth will get a lower cost. So compare the cost, the smallest cost value will become the RP. If the cost is same, we will compare the bridge ID. Of course, the same compare. Compare the bridge ID priority at first. Smaller one is better. If the priority is same, we will compare the MAC address. MAC address smaller is better. If the bridge ID also same, we will compare the port ID. Also, smaller is better. And the port priority, port number. So we also can change the cost to select who will be the root port. For example, enter the interface to change the spanning tree, the cost value to become maybe 2000. Or maybe we can directly to change the port priority. So this is the second one. And the third one, we have to select the DP. Every link, at least one DP. And this interface also can use to follow the traffic. Compare the cost at first, compare the bridge, and compare the port ID. And the parameter is same like the RP. And the last step, all the interface will block. So this is a process, how to select the STP, and who is a root bridge, who is a RP, who is a DP, and a block. And later, I will show you an example. It's more easier to understand the STP. For example, now there are 3 switches, 1, 2, 3, and I change the priority to become different value. And every link, the cost value also different. But in your real network, maybe the parameter is different. So first we have to select who is RP, right? Who is a root bridge. About this topology, 1, 2, 3, who will become the root? Who can show me the answer? 1, 2, 3. Who will become the root? Switch 1, right? Because we have to compare the priority at first, right? Smaller one is better. So switch 3 will become the root bridge. And the second step about non-root bridge is switch 1 and switch 2. We have to select one interface to become RP, right? So about switch 1, we have 2 interfaces to connect with the switch 3. Of course, actually we have 4 interfaces, But there are two interfaces to is used to connect with the terminal. So we only select the first interface and the second interface. Which interface will become the RP, root port? Directly interface to connect with 3 or the second interface to connect with switch 2? Who will become the RP? Root port. About switch 1? Should be no answer. We have to compare the cost value at first, right? One interface directly to connect with switch 3, the cost value is 100. But this interface to connect with the root bridge is 300 plus 200. The value is higher than 100. So the cost value 100 will become the IP. And the same process about switch 2 should be IP, right? Directly to connect with switch 3. And then we have to select who is DP. One link, at least one DP. So about switch 3, this link, one interface is IP, so the other interface will become DP. And about the same link, this is IP, so this will become DP. But about this link, which interface should be DP? Also, the first compare with cost value, right? This interface, the cost value is 100. This interface, the cost value will become 200. So smaller one will be better. So this interface will become DP. Then we will block the interface. Okay, we will block this interface. That means if all the link can work, all the devices can work, this interface cannot forward the traffic. At the sixth time, how to forward the traffic? PC1 will send out the packet to the destination to switch 1. Switch 1 only will send to switch 3 because this link now we cannot forward the traffic. And the switch 3 will forward to switch 2. Finally, switch 2 send to the destination. So this is the normal scenario. But if this time the link between switch 1 and switch 3 is broken, let's say the process, we will enable this interface immediate 30 seconds later. That means this link also can be worked. And later, switch 1 send out the packets to switch 1. Switch 1 will use this link to forward to switch 2, and then forward to the destination. So this is a function of STP. We also can use the STP to get the backup configuration, and also we can avoid the loop. So this is the configuration, and we see about the rule. We have different one block. Finally, the port will be blocked, and all the other interface will become RP or DP. And all the interface we have different status: blocking time, listening, learning, and forwarding. And at the last, RP and DP will keep the state of forwarding, and the blocked port will keep the state of the blocking. But listening and learning only is the media process. So different status, they have different action. Two types. First package for the BPDO is used to select the rule of the STP. The second one, learn MAC address, and finally to forward the data. And the different rule, we have different action. Blocked port, keep the blocking status, only can receive BPDO from other switch. This interface cannot send out the BPDO, cannot learn MAC address, cannot forward the traffic. And finally, the RP and DP will keep the forwarding state and receiving BPDO, sending BPDO, and also can learn MAC address, finally help us to forward the traffic. And in the media state, listening and learning, Listening time, we can receiving and sending. Actually, we receiving BPDO or sending the BPDO is used to calculate the STP, right? Learning forwarding, learning MAC address is used to finally to forward the data. Between the medium, we have the time limit of 15 seconds. So this also is a disadvantage of STP. The time is too long. This is a status. It's okay. Maybe I have a question for you. If you can answer this one, maybe I think you already get the configuration or get the principle of STP. Which of the following statement about the status is incorrect? Which one is incorrect? Yes. Already have the answer? A, right. A block interface. The wrong is blocked interface can receive the BPDO but cannot send out the BPDO, right? Why they have to receive the BPDO? Because I have to make the detect. If the other side is cannot work, I will have to enable my interface immediately to forward the traffic to provide the backup function. So the option A is wrong, but the rest of the other question is correct. It's easy for you to understand, right? The configuration of STP is very easy. Maybe you only need to enable STP, then they will select the root bridge and decide the BP, RP automatically. So you only to enable, it's okay. Yeah, it's blocked already, but this interface still can receive. Okay, so we see about the STP, one disadvantage is if you want to enable the block interface, we need time to wait, at least 30 seconds. It's very long. And another disadvantage of the real network, sorry, I have to unmute the information at first. Yes. Okay. What's another disadvantage of STP? Let's say this topology is here. Now our company is bigger than before, and we have a different layer switch, access layer, distribution layer, and about distribution layer between different devices, we connect with multiple links. In this scenario, we want to get higher bandwidth and also can provide redundancy backup. How to solve this problem? Because maybe about this part, we can use the STP to avoid the loop, right? But between the switch 3 and the switch 6, we have 3 links. If we use STP, at least 2 interfaces will be blocked. Otherwise, there is a loop, right? If one interface we have 1 gigabit bandwidth, that means totally 3 gigabits, we only can use one in the same time. If one link is broken, we can use the second one. But if we want to use the totally bandwidth, how to solve this problem, how to meet this requirement, we can use link aggregation, right? What's the function of link aggregation? The link aggregation means we can use the physical link to become a logical link, right? And about the customer, they will think I only use 1 link to forward the traffic, but the totally bandwidth is 3 gigabit. So this is the advantage of link aggregation. And about the link aggregation, we have to select who is port aggregation. Is this one, port aggregation. And how to add the configuration of link aggregation, we have two types. One is static and another one is dynamic. But both of them, we have the advantage. We can extend the link bandwidth. For example, totally 3 gigabits can be used. We also can use the traffic balance. That means all the link can follow the traffic at the same time. And we also can provide the automatic link redundancy backup. So this is a good advantage of the link aggregation. And how to make the configuration? We say we have two modes. The first one is static aggregation. The second one is dynamic. Static means both sides we have to add into the aggregation port manually, and they will not exchange any information with the other side. But dynamic aggregation means we will use a protocol we call it LACP, and both of the switch we have to send out the LACP packets and to negotiate some parameters to select and decide which interface can work, which interface cannot work, maybe finally cannot be selected. So this is a dynamic. And both layer 2 and layer 3 ports of the switch support the port aggregation, both the static and the dynamic. And about the detail, how to select who is the AP and how to select who can make the link aggregation member, and finally to follow the traffic. The detail you also can see maybe on the RCNA certification course. But here I will explain the detail one. We say link aggregation can provide the traffic balance, right? Besides on different parameters, we can according to the MAC address information, IP address information, and both the MAC address and IP address together. Something like this. Finally, to decide which interface, which packets can use which link to follow the traffic. And how to select this one, or how to check what's the balance mode, we can use a command, show aggregate port load balance. For example, about this switch, the load balance mode is source IP and the destination IP together. That means the traffic with the same source IP and the destination IP, they will use the same link to forward to the destination. So this is the load balance. And the main configuration, this one is too long. Okay. The configuration of static aggregation, we have layer 2 and layer 3. About the layer 2, we can enter the interface and then to set the aggregation port number to become 1. Of course, if the link aggregation port number 1 is not exist, this command will be created automatically. And then we can enter the aggregate port 1 to directly change the mode to become chunk. That means the physical interface 1, 2, 3, both of them will use the VLAN mode to become chunk. And then we can decide the aggregation ports, the load balance depends on the source and the destination IP address. So there is a layer 2 configuration. About the layer 3 configuration, we can create the aggregation port at first. And the no switch port means we make the interface to become layer 3 interface. By default, there is a layer 2 interface. About layer 3 interface, we can add the IP address. And then about the physical interface, we also have to change the mode to become layer 3 and add into the aggregation port. And finally, in the global, we can decide the load balance besides on the source or destination MAC address. So this is a configuration of the layer 2 and the layer 3. But by default, the aggregation is static. And about the dynamic, a different one is Between switches, we have to send out the aggregation packets, the LACP packets, and then they have to do the negotiation. The configuration is very similar with the static one, but the difference is like this. Enter the interface. We also add the interface into the link aggregation part, but we have to change the mode to become active. If we don't add this command, the default mode is static. If you configure the one site to become active, the other site also should be active. If one site is static, the other site also should be static. The other configuration are same with static. We also have to add the physical interface into the logic, into the link aggregation port. And about layer 3, we can add the IP address, and we have to change the layer 2, the mode to become layer 3, interface. And the layer 3 aggregation, we also have to change the mode to become active. That means we will use the LACP. So this is a link aggregation configuration. And later we can check show aggregation port, and what's the port number, what's the maximal port number, what's the import mode, and now is access, and what's the physical interface. About the link aggregation, we have the limit of maximal number. Pay attention about this one. For example, here is 8 ports. Someone say I want to use 100 gigabit, so I use 100 link. It cannot work. Okay, we have the limit of the port, 8 ports. So this is a link aggregation. Now it's clear for you about this part. So we talk some technology about the switch, right? Switch, how to work, and how to learn MAC address, and how to forward the packets according to the information, according to the MAC address. Oh, thank you, very clear. Yes. Oh, the first question, the answer is A. Okay. And besides the switch, we also explain something about the VLAN, right? Use the VLAN, we can limit the broadcast domain. But if we want to avoid the single failure, we can add more devices and more link on our network. But we have to avoid the loop. So we use one protocol is STP. Of course, pay attention. STP is not only solution. We also have another solution to avoid the loop and also provide the load balance. Also provide the backup function, like the link aggregation mode, like the VSU, like the other technologies. But today I only explained 2 backup solution. One is STP and another one is link aggregation. So here is a very useful and basic function of layer 2 switch. Okay, the main principal technology. If you are clear, maybe we have to talk about the next part, about the DHCP. DHCP also is very useful because about today's training, we explain 2 PC directly connect with each other, and then they can use a cable to forward. If the network to become complex, we use VLAN, we use STP, we use link aggregation. But what is the function of DHCP? Actually, you can think this is a technology used for the terminal. Because all the devices, yes, automatically provide the IP. Because all the devices like the terminal, our PC, our client, they must have the IP address and then they can work, right? And of course they need to have the MAC address. But by default, all the network card already gets the MAC address before. But how to assign the IP address for the client? One way we can use a static way, right? That means everyone configures the IP address manually and to give the IP address. The second one, we can assign the IP address, yes, static. And the second one, we can use the DHCP server to assign the IP address. Because about the DHCP server to assign the IP address, there's some advantage. Of course, have some disadvantage. For example, if now we choose a manual way to give IP address, subnet mask, yes, and the gateway and the DNS manually. So this is a configuration of the manual way, step by step. But in our network, not everyone know what means IP address. I think today everyone know what means IP address, right? But I also know IP address, but my family, they don't know what means IP address. So maybe they don't know why the number should be 192.168.1.1. They will give a wrong IP address. So if we give the wrong IP address, there's some disadvantage. Although everyone know how to make the configuration of static way, but the mentors, for example, our Reyee engineer, and also show you a table. Your laptop should use this IP address, but the other laptop should use other IP address. But no one maybe care about this one. I will give the wrong IP address. Then there is a conflict. Or maybe they give us different segment of IP. They cannot visit the internet, right? But all the terminal, if I cannot visit the internet, I only have one solution, found my engineer. I will call my engineer, come on to solve this problem immediately. And you maybe ask what's the IP address. The terminal maybe say, I don't know what means IP address. So in this scenario, typical, maybe our terminal is very, in our network, there are many terminals. We hope we can have one solution. Reduce the difficulty for users to configure IP address, because about manually way, you have to create so many parameters, right? And we also want to reduce the workload of the network center staff. For example, if you manually, maybe there's some conflict. And we also hope there is a way to avoid the IP address conflict because of the misconfiguration. So in this scenario, maybe we can use the DHCP. Yes. And about the DHCP, we have the CS architecture. So in this scenario, we have one device to become DHCP server. S means server, C means client. And the client may be your laptop, maybe your PC, maybe your phone. This one we call is DHCP client. And the client will ask for the server to help. I want to get IP address. Can you help me? Something like this. So between the client and the server, we will use the DHCP protocol to ask, I want an IP address, and give a reply, which IP address you can use, something like this. And the configuration on the server, we have to enable the DHCP server at first. Then we have to configure an address pool and IP DHCP and the pool name, Ruijie. You can use other name like test, like 123. It also can work. And in this pool, which segment IP address can be assigned? This is a network IP address, and the default route ID is a gateway, and who is a DNS server. Then about your client, you only need to select the IP assignment to become DHCP. Oh, it's similar to Cisco. Yes. Every command is similar. And also about the DNS, you have to select automatically about the DHCP. It's enough for clients, right? And later, we enter the DOS to check your IP address is enough. Of course, between your client and the server, if you use the layer 2, the broadcast domain have to be the same. Otherwise, the DHCP packets cannot send to the server. I cannot get the reply. So about the client, it's very easy to finish the configuration. Yes. And the main process about the client, I will send out the DHCP discover. This packet is used. Is there some DHCP server or not? Of course, when your client, if you select automatic or select DHCP, they will send out the DHCP discover packets automatically. We don't have to do any configuration of the client. And then the server will give a reply, DHCP offer. That means I can have the function to assign the IP address. Then the PC will give a request. Please help me. I want to get an IP address and the mask and the gateway and the DNS, and later I can reach the internet. So the server will give a check acknowledgement. So these are the main parts on the DHCP. Includes 4 packets. So after we exchange these packets, later we can get the IP address. So PC can use this IP address to visit some destination. Of course, if you have the tool to get the packets like the Wireshark, you can get this information. Okay, the configuration is very easy about the DHCP server. You only to assign the IP address is enough. To assign the IP pool. It's easy, right? So this is a DHCP. Especially in our network, maybe your office, maybe your hotel, maybe some other scenario. Your terminal is so many, and they want to get IP address. In this solution, maybe you can use the DHCP to assign IP address for the client. And another scenario, if in our network we deploy the wireless network, our terminal maybe is our PC, maybe is our phone, also have to get an IP address. And in different time, maybe we access in our network, the time is different. So in this scenario, we often use the DHCP to assign the IP address. Okay. So today about the where the network part is finished, we explain some technology, right? How about the switch work? How to use the VLAN work? How to use the STB to provide the backup and also avoid the loop? How to use the link aggregation to increase the bandwidth, and then also can provide the backup function. And if in our network there are many terminals, we also can deploy DHCP to assign the IP address for the terminal. So the basic layer 2 function we finished, and we can use this layer 2 function to finish to meet the requirement within the same VLAN. They can communicate with each other. And the next step, the customer also have another requirement for our network. Now we can provide the basic service, but the customer want to build a wireless network besides on our wired network. So our customer use a phone or maybe use a laptop can directly to connect with the network and then to visit the internet. So how to solve this problem? How to meet this requirement? We can use the wireless network, right? Maybe to deploy the API, and the API can send out the signal, then the client can connect with our API and finally to reach the internet. So this is our solution. Yes? Use API, use mesh. Yes. So before we deploy the wireless network, maybe we have to check our wired network can work or not. And then, before we talk about the detail, let's see the components of our wireless network. The first one is a station. What means station? Station is a terminal who want to use the wireless network to visit the internet. And this station have to support the special protocol for wireless is AO2.11. Okay, and AO2.11 is a special protocol for wireless. The Ethernet protocol is AO2.3. And later is the access point is the API. And about the API is connected with the wireless network and wired network. So I will receive the packets from the station, and the station user protocol is L2.11. I have to transfer the packets to become L2.3 protocol. So I can use a cable to forward the traffic on the world network. So this is a function of AP. And AP also have to send out the signal, and the terminal, the station can use the function to connect with the SSID and connect with the wireless network. So this is a function of the AP. And in our network wireless part, maybe we also will use another device we say is AC, access control. In this scenario, maybe we often will use the AC and the fit AP together in the bigger network. That means some function will be finished on the AC and some function will finish on the AP. And we can make the wireless network bigger. And the first component is the wireless media. And the wireless media means I can use this one to send out the signal, like the 2.4G and 5G, something like this. And this like the function of the cable, but we cannot see the we cannot see the wireless media. But the cable is very similar. We can directly to use. And about the wireless part, we also have the cable to connect with the terminal and the AP. So there is the components. And how to use a wireless part? We have some solution. The first one is a FAT AP. FAT AP means we will use the function, all the like signal, like the encapsulation, like some security function, encryption, and also provide some QoS function. All the function we can finish within one device. And this device we call is FAT AP. So FAT AP means we use a single AP and can provide all the function of the wireless. But some function is not so rich like the FIT AP and AC together. For example, about the roaming, we only can provide layer 2 roaming. And if in our network, the office or maybe the hotel is very big, we have to finish the configuration about AP step by step, one by one. So the configuration is very big, not so complex, but very big. So in this scenario, maybe we will use another solution. But about the FAT AP, first, we have the AP 2 mode. The first one is FIT AP, the second one is FAT AP. FIT AP have to use with the AC together. But about the FAT AP, we can directly to make the configuration for the AP. And one solution is uses command. And the second solution, we can use a web. And if we want to use a web to finish the configuration, we have to connect with the web at first. And the AP, we have the default IP address. About the FIT AP, we have 2 LAN interface and the IP address is same. But about the FAT mode, the IP address of LAN 1 and LAN 2 is different. But finally, depends on the real device. Okay, depends on the real device, maybe a little different. But about the FIT AP, we have different type interface. The first one is USB. The second one is console. And about the console, we can use a console line to connect with this interface and then use the command to finish the configuration. The second one is the physical interface, maybe is LAN 2 and LAN 1. Some LAN 1 interface also can provide the PoE function. PoE is a power over the internet. That means we can provide some power for the terminal if we use a cable to connect with this interface. And the next one is the local power. So we have different interface. And we can use a cable to connect with the console interface and use a command to finish configuration. And we also can use some network cable to connect with the LAN interface and use a web to finish the configuration. Different login way to finish the configuration. And later about the FAT AP configuration parameter, let's see. For example, in this topology, we have deployed the access switch to connect with AP, and the AP provides a wireless function for the station. And now the planning is AP will also have an IP address. Then the AP can work for the traffic. The IP address of AP is 172.16.1.250.103, and the gateway is 254. And about the client is the same segment of AP, same gateway of AP. And now the VLAN of client and the AP is the same VLAN, VLAN 1. The SSID name is Ruijie. So about this planning, how to use the command and to meet the requirement. The first configuration, before we do the command, we have to check the basic power is okay, can work. Okay, maybe you can check the indicator. And then we have to make sure the network cable can work. That means where the network part can work. You can use a computer to directly connect with the access switch and to test the basic configuration, for example, ping successfully, and also can get an IP address from the DHCP server, and then you can change the laptop to become AP. That means where the network part is finished. The next step, we have to finish the basic configuration of AP, like the WLAN configuration, like the SSID, something like this. Then the AP can broadcast the wireless SSID. Later, we can use our client to connect with the SSID and then to test the connection. So this is the main part of FAT AP. About the other optional configuration like the channel optimization, black and white list, like some authentication, something like this. All the configuration belong to the optional configurations. That means if you not add this configuration, our client still can connect with SSID and to visit the internet. But maybe if we add the optional configuration, our experience will be better. For example, maybe we add the black and white list, and the client maybe can get a higher bandwidth. So this is a configuration. And the key command of the switch of the AP, we have to switch the mode to become the FAT AP at first, and then create the VLAN and the name for station, and then configure the wireless signal. This is a configuration of the wireless part, WLAN part. .11 W1, .11 is a special protocol for wireless, right? And this is a key command. One is the WLAN number. You can use WLAN 2 or WLAN 3. And then this configuration, we have to use the VLAN 1 to connect with each other. That means if AP gets a configuration from this command, we will use the VLAN 1. And we can broadcast the SSID. So finally, the terminal searches the SSID. We can see the name. And the SSID name is Ruijie. You also can use the other name, depends on your real network. And then we have to binding the WLAN to a special wireless server interface. And we can see the wireless signal. The command is this: interface.1.11 radio, and we depends on your AP. Maybe your AP only support one channel, is 2.4. Maybe support two channels, 2.4 and 5. So maybe we have different server interface. And about the interface 1.0 encapsulation, the protocol is .1Q1. This is the VLAN information, and then to associate with WID, WID1. And this is the main configuration about the FAT AP. And then we can configure AP interface and about the IP address and the routing information, like the Ethernet, enter the interface and to encapsulate the .121 and configure the VLAN interface IP address. This is a virtual interface of VLAN. So we can provide the layer 3 information to forward the traffic of different segments. And also configure the static route, the destination 0, the mask 0, and what's the next step. And configure the DHCP address. Of course, in your network, the FAT AP also can finish the configuration of a DHCP server to assign the IP address for client. But another way, maybe we also can directly use the switch to become a DHCP server to assign IP address for client, maybe also for AP. But for AP, this is used for, on the FIT AP mode, typically. Of course, about this part, we can add into the switch. If we already use a switch to become the DHCP server, we can skip this part. Okay, so this is a FAT AP. But in the FAT AP, we also have the disadvantage, right? Each AP needs a separate configuration. So maybe in your network, you have multiple AP. You have to configure the same configuration one by one. It's very, the working is very big. And maybe if some client cannot visit the internet, you have to check step by step, one by one. So it's not very convenient to use a FAT AP. And how to solve this problem? We have two solutions. One, we can use the Ruijie Cloud for unified management operations. That means use the FAT AP and the Ruijie Cloud together. The second solution, we can use the AC and the FIT AP networking together. And finally, we use the FIT AP. We use the AC to control the FIT AP. So there are two solutions. And later, we will explain how to use the AC to meet the requirement of FIT AP together. This is the next part. So the time is 4:10. 5 minutes for you to break is enough. Come back, we will explain the information of the AC and the FIT AP, and the next part is the Reyee service. So this also is very important for us. 5 minutes is enough for you. We can see some detail about Ruijie products, okay? Please come back maybe 4:17 minutes. Yes? Okay, I will show you a video too. please come back. Please come back. We will continue the next part. Oh, already here? Oh, let's continue. Okay. Yes. So we say if we use a fat AP, there is a disadvantage, right? About the management is too complex. And if we have multiple fat AP, we have to finish the configuration one by one. So we have two solutions. One use Ruijie, Cloud, and the fat AP together. And another solution, we can use AC and fat AP together. And to the rest part, I will explain about the second solution. If at the last, I will have a format surname for you. If you are very focused on or maybe interested on the Ruijie Cloud, maybe this one will be the next public training. Okay, so today, the rest part, I will explain the second solution. How to distribute deploy the AC and the fit AP together. About the fit AP working mode, first, if we want to use a fit AP, and this one have to connect with AC together. And the fit AP will be responsible for the function of the wireless access, encryption, and authentication, but the management and some, for example, roaming control will be done on the AC. So we have different function of different device. And between AP and the AC, we will use a cable of cap web. This one is very important. And this one uses a special port number. And in our network, if you do some access control or maybe you deploy the firewall, you have to allow the port number. Otherwise, the AP and AC cannot work. This also is a troubleshooting step on our network. So between the AP and AC, we will establish the cap web tunnel. And this is the main working principle of the fit AP. This also is the principle. If you deploy the fit AP and AC together, but they cannot work, you can, according to this step, to finish the troubleshooting. If we want to deploy fit AP, the first we have to keep the wide network set up successfully. For example, finish the VLAN, the DHCP, the routing. Maybe you also have some layer 2 high available technology. You have to keep this part is correct at first. And the second step, when AP gets the IP address from the DHCP server, if we deploy the fit AP on our network, we have to give a special DHCP parameter. This one we call is option 138. Because AP have to establish the cap web tunnel with AC, right? And why AP can know who is the AC and how to find the AC to establish the tunnel. We will use the option 138 and set the AC IP address for AP, and then AP will establish the tunnel with AC. So this is a third step, establish a cap web tunnel. And we have two tunnels, one for control and one for data. And the fourth step, AP and AC step tunnel successfully, then the AC will send the configuration information to the AP. Of course, you have to add the configuration on AC at first. Then AP will get the configuration and broadcast the SSID for the terminal. And the terminal can search online and connect with the SSID and then send the packets to AP. When AP receives the packets, we will use the cap web tunnel and encapsulate the packets and forward to the destination. The packet's destination is AC. But AC will decapsulate the packets and forward the traffic to maybe to the internet. And this is the next step. AC will receive the packets and decapsulate the packets and then to forward. And about the wireless part, about the word part network, I receive the packets and then I will send to AC. AC will use the tunnel to send to AP again. AP will transfer the Ethernet L2.3 to become wireless part L2.11 and to the destination to give the terminal. So this is a process of the traffic. Okay. To hardware AC have a roadmap to support the captive portal. You mean the portal authentication? We can use the Ruijie cloud to finish the portal authentication. And about the AC, you also can use this function and provide the portal server. And about the portal server to provide the authentication to connect with the portal server. So this is a function. And let's see the detail. About the wired network part, like this topology, there is a switch, distribute switch, access switch, and connect with AC and connect with AP, and there is a terminal. First one, we have to make sure the wired network set up about the VLAN, DHCP, and routing. Then let's see, the switch will create the AP VLAN. Maybe the VLAN is 20, the station VLAN is VLAN 10, and also the gateway IP address. And the switch also is the DHCP server, and assign the option 138 for AP. So this is the IP address of the switch. And the command of the key value is, so first we have to enable the service DHCP, and the port name is AP address. Option 139, 138. This is used to tell the AP who is your AC. The AC IP address is 1.1.1.1. Of course, you have to create this IP address on AC at first. And what's the network segment? 20, and there is a mask. And then the default route is a gateway. But this is the IP address on the switch. So switch is a gateway. And the other part, this is a configuration for the DHCP part. And another part for the switch, we have to configure a static route on the AC interface. Because between the switch and AC, they have to communicate use the layer 3 interface. This is a key command. And about the AC, we have to configure the default route to the switch. Like this one, 000, and the destination IP address is the switch. And later, about the AC, only creates the VLAN 10 for the station is enough. And about the access switch, we have to create the VLAN 20 for AP. And about the downlink to connect with AP, the downlink interface, we also have to create the access switch to VLAN 20. And this is used for AP SOL. In this part, there is a question. As the only way for the station date, why the station VLAN not created on the access switch? For example, that means in our network, the terminal station will use the VLAN is VLAN 10. The AP use the VLAN is VLAN 20, right? Finally, if the station connects with AP, AP will forward to access switch, and then forward to the distribute switch, finally maybe to the internet. So why about the access switch? We only have to create the VLAN 20 is enough. So how to forward about the VLAN 10? About this question, after we explain the whole process, I hope someone can answer me the question. It's okay? Why we don't need to create the VLAN 10? Okay, so the next step, AP start with a 0 configuration. That means if AP gets the power to connect with our wired network, we don't have to do any configuration. We can directly get the configuration from the DHCP server, get the IP address, and also get the AC IP address. So between AP and the switch, we will get the information from this command on the switch. And finally, about the AP, the IP address is 20.0.0.1. The gateway is 20.0.0.254. And the option 138 is 1.1.1. And the next step, the AP will establish the CAP web tunnel to AC. Establish. I will send out the CAP web request, and then the AC will give a reply. So we establish the tunnel successfully. Pay attention. About this packet is unicast packet. I will add the source IP address. This source IP address is AP IP address. Destination IP address is the AC IP address. The destination IP address from option 138, right? And then we will use the packet, the protocol is the UDP protocol. Also will give a reply. So later, after we establish successfully, then when we do the configuration on the AC will send the configuration information to AP, use the CAP web tunnel, control tunnel, includes the SSID, the WLAN, VLAN mapping, the security parameters, some radio channels, some power information, something like this. So we will use the CAP web tunnel and use the unicast packets directly sent to AP. About the call switch or maybe access switch, they will think this is a normal user traffic, directly forward to the destination. Okay, and the next step, after AP gets the configuration, AP will broadcast the SSID for the client, right? And the client will directly to connect with the SSID and then to give some information for the request. Yes, we'll scan the SSID and join the WLAN. The AP, when AP receives the packets from the client, we will convert the wireless protocol to become the Ethernet and then forward to the AC. So this process like this. After the AP receives a DHCP request from the station connect with the SSID also have to get an IP address, right? So I will send out the DHCP request. This is a wireless protocol sent to AP. When AP receives these packets, I will convert to the Ethernet packets. That means we will delete the AO2.11 and to become AO2.3 and also add the VLAN tag is VLAN 10 and then to add into the CAP web. The CAP web tunnel, we have the UDP protocol and add to layer 3 information, the source MAC address, the source IP address is IP address of AP, the destination IP address is from the AC, and then the packets will be forwarded to the destination is AC. So about the switch, the core switch, the distribution switch, I don't know, this is the information of the DHCP request. I don't know this information. I will think this is a unicast packet and I have to forward the packets from the source to the destination. And when AC receives this packet, I will do the de-encapsulation. That means I will delete the information, delete the UDP, delete the CAP web, and I will find the packets. The VLAN is VLAN 10. And who can deal with the VLAN 10 information? This is the function of your distributed switch. So I will use the trunk link to forward the traffic for the distributed switch. And the distributed switch also is a DHCP server. So later, the DHCP server will assign the IP address and send to AC. And the AC will encapsulate the packets again. So AC will update the MAC address and assign the IP address from the IP address pool and also return a DHCP response. This is a function of the switch, okay? And the AC will encapsulate the response packets and then to encapsulate, to add the source IP address and the destination IP address, to use the UDP again, to use the CAP web tunnel, and then use send to the destination is AP. And later, AP will transfer the Ethernet protocol to become wireless part again, and to the destination is the client. So this is a whole process. In this process, The distribute switch that knows the information of between AP and AC. I only for the unicast packets to the destination. So this is the whole process. Pay attention. We have 2 forwarding modes. About these 9 steps is the centralized forwarding mode. So the switch can directly use the protocol and to forward the traffic. And another solution is the local forwarding solution. This is a little different. In this centralized forwarding, all the other parameters or the packets from the terminal, like the ARP, like maybe some traffic to visit the internet, is same use the tunnel and then to visit the destination. So this is the main part of the centralized forwarding. So now who can answer me why about the AC? We only need to give the create the about the distributed switch, about this switch. We only have to create the VLAN 20 is enough. We don't need to create VLAN 10. What's the reason? Who can show me the answer? Can I get a recording? Oh, of course, everyone can get. If you already fill in the register of the email, and we will get the email address for you, and we will send the information for you by the email. So who can show me the answer about the PoE access switch? Why we only have to create VLAN 20 is enough. We no need to create VLAN 10. Why we don't need to create VLAN 10? That's because about the access switch, we receive the packets from AP. AP already add the tunnel information, right? The VLAN 10 information already be added into the cap web and the UDP and the source and destination IP address. That means when PoE receives the packets from AP, the PoE switch, access switch, cannot see this information. I only add the VLAN 20. They will think this packet from AP. The access switch doesn't know the information from the client. Who will know the information from client? Access, right? So access will distribute the packets to the distribution switch, and the switch as a gateway will do the next step. So this is the main reason. Okay. So compare with the fat AP and the fit AP, we have different attributes: the security, the network management, and the configuration management. Some advanced feature is also different. Okay. And this is a comparison. Of course, this not means the fat AP is worst, or maybe fit AP is the best solution. Depends on your real network. If maybe, for example, in your office or maybe in your hotel, you only need 2 AP is enough. Maybe fat AP is more better for you. And if in a bigger network, you want to use something to control them together, and the fit AP only need to get the power is enough, or the configuration will finish by AC. We can use a fit AP and AC. Of course, in your network, maybe you already deploy multiple devices for fat AP or maybe fit AP. You can also use a Reyee cloud to finish the configuration or finish the management. So we have so many solutions. Today, I only explain the technology for you. It's okay. Or you can send the email to me, but later, not finish. We also have the third part, okay? So about this question, which of the following stated about AP networking mode is correct? It's correct. Please get a hi. Can I get a record? Of course, everyone can get the record, okay? About this question, which answer is correct? About this one, the correct answer should be A and B, right? A and B is correct. But C and D, what's wrong? In C, the wrong configuration, centralized mode of AP access, the switch only need to create the AP is enough, right? The terminal no don't need, because about AP already finishes the encapsulation of the cap web tunnel. Okay, the last question. SSID cannot be encrypted in FAT AP. SSID also can be encrypted. For example, you give some password and the client have to use the correct password, and then we can visit the internet. So the answer is A and B. So about the technology part is okay now, right? And the most important part actually is the third part. Let me see how many people still exist. This part is very important part, okay? Because maybe today's training, you get so many technologies, right, from me, but I don't tell you the detail. For example, how work about ARP, how work about the STP, and you want to know the detail, or maybe in your real network, you get some troubleshooting problem, or you want to download some files, the Ruijie service and support is the most important for you. So please focus on this part, okay? First, about the technology support resources. Not only about the public training, we also have another technology support resources. The first one is the service portal, like this one. Service portal, we can use this page to get the unified support resources index platform, like the tool of the Reyee, and also we can get some wireless intelligence service. Also, we can get some communicate information, some training videos, something like this. So I suggest you can directly to add this link in your maybe web page. And sometimes you can directly to enter here to find which solutions you want to get. Some technical support, some tools, some service support. So about the case portal, we support the technology support request. An official way to request the Ruijie technical support includes the technology or maybe some troubleshooting. Maybe when you do project, you have some problem, you can directly use this tool. And also we can use some RMA client, open of hard failure. And you can use this tool to register and to get hardware and to replace here. And also we can use the case portal to get some warranty period requirement. Okay, so there are 3 tools. And also very useful tool is Ruijie Intelligent Technical Assistant. For example, today I'm maybe confused about the STP, maybe confused about the switch, or maybe the switch of which series. You can directly to use this tool to get some keywords, and we can get so many replies. So this one is very useful. And you can also record the URL address, or maybe directly to use the first URL and then to enter the Reyee. And we also support the live chat support. For example, this is the address and the working hour from 9 o'clock to 11 o'clock, and 1 week, 7 days. So we can provide the web-based live chat and get support from anywhere. And here is the local and global service hotline information. And the upcoming hotlines in different states, and we have so many countries. And now we have multiple countries already supports the hotline, different time, and both of the hotline is English speaking. And about the Thailand, we can support 24 hours every day. So this is a hotline service. And we also provide the community. You can share your idea, maybe the technology, maybe the case, or everything you can share here. And my colleague will answer you, or maybe will select the hot page to share with others. So this is a community. And we also have the Facebook. So because I know about today's participant, someone gets the public training information from the Facebook page. So if you use this tool, please follow us. We will share so many information. Also like this, also today's training information, we will share the link on the Facebook so you can download and recognize maybe the next month what's the global training information. You also can join. And we have authorized the service part. And in this country, we can provide the local language, the native languages. So it's better for us because not only about the global training, global public training, we also have some certification course like Reyee, like Ruijie. And if you are in these countries, you also can directly to connect to someone and to join the certification course. It's free and it's very useful. So about service level agreement, we support the on-site support. On-site to discuss the troubleshooting about the course and the solution. We also support the live chat and the case portal. We can support the local ASP service hot online. And we can support the global service hot online. And also we provide the Reyee. You can get so many answer and some document from the Reyee tool. So this is the first part. And this is the second part of the training and certification. This is a part for me. And we have multiple certification for the engineer. The first one, we provide the products certification of ISE, Reyee, and enterprise of Ruijie products. And also we will update a new certification for the cloud. Besides this one, we also provide a certification for the trainer. So if you want to become a trainer like me and to have a trainer for your customers, you also can join this part. And in the future, we will update the course. And within here are some limitations, how to get the information from the ISE and what's the time limitation of this certification. Besides this certification, we have very useful one is RCNA, right? If you receive the email or maybe from other tools or from the FB, you already see the detail how to get the e-learning account and how to get the RCNA certification. Because about this part, explain some typical and basic technologies of the network. So this one is very useful. If you get the RCNA better, and later you can study Reyee or study Ruijie or study cloud, it's easy for you to understand. So this is about the training. So this is a page. If you can log in successfully and see the roadmap here is by default. You can see the RCNA certification, and you can see the video and to answer the question and finally to get the certification. The last part is the warranty policy. And we provide multiple products and warranty and support summary. And by default of the devices, the warranty duration is 3 years, but the RGNBS is 5 years. and some AME, DOA, and written for the repair relationship and the replacement service. Some all the devices support except these two switches. And here also have a link. We can see the detailed information. And about the material, I will show you later, and you can directly to click the link to see the detail. And here is a service product overview, and what's the unit, and the slave agreement, and the service contact. Here is a detailed one. And when we can get the replacement devices, and how many times, how long, something like this. Okay, that's all about today's training. So now it's time for question discuss. Everyone can open your voice and ask us a question. And of course, I hope you can spend several times to finish our souvenir about today's training to get us more feedback. Later, my colleague will show you about the link. Are you single? Sorry, I get married. Okay, so please. No, why we have two links? Okay, so I hope you can fill maybe 3 minutes to fill in the evaluation. And I hope you can give me more suggestions, maybe about the next topic, maybe about today's training, any suggestions to improve the training better. Okay. But we can discuss technology together. Please fill in the link. It's very useful for me, okay? Yes. Please fill in the link. Otherwise, maybe it's difficult to share you about the recording. I will show you everything. If you finish the link and no question, today's training is over. Thank you everyone to join the training. Thank you very much. Yes, I will send you the slide and the recording. Thank you so much.
Thank you, Mom.
Thank you.
Thank you so much, Mom.
Thank you.
Thank you.